Hi, in this video we're going to talk about doing text analysis with R. So just like many other things that we've done in the class, we're going to take a tidy approach to this. And in doing so, we're going to use a package called tidy text. What this package enables us to do is to use tidy data principles to make many task mining tasks much easier, more effective, and consistent with tools that we've already learned about. There's a really nice book called Tidy Text Mining with R, or Text Mining with R, at the address tidytextmining.com. So if you're interested in reading more about it, I strongly recommend that you give that a visit. Some of what we're going to cover in this video is in the first couple chapters of that book, but obviously the book goes much beyond what we're going to be able to cover in this class. So what do I mean by tidy text? I'm going to start with a small example before we dive into our longer case study. Here is lyrics from one of my favorite songs by Belle and Sebastian. What I've done here is I've created a vector called text. That's what I'm calling the vector. And the vector has 12 elements in it. And these are 12 character strings. And each of them corresponds to a line of a lyric from this song. Okay, so we can see that each one of these entries in the text is a line from a lyric. This could be in text analysis if we're working with song lyrics. This is exactly how things would look like if we were working with books. It might be the line number in a printed book or a sentence or a full document. But we are often thinking about text coming to us in a vector like this, whether on its own or more likely in a data frame, just like with everything else that we've done so far. So here I've taken that text and I have put it into a table, and I've also added one more variable to that table called line number, because I want to keep track of the line number from the song. So these were the first 12 lines of the lyrics, so I've numbered them 1 through 12. So we can see that now that vector actually is just one of the columns in this data frame that we have. The idea of text analysis usually then breaks this up. Oftentimes, we're not working with these full lines at a time or a full sentence at a time, but breaking it down into the words first and then doing some analysis with that. There are natural language processing methods that can actually work on the full sentence as well, but for kind of an introduction to this topic, we're going to start a bit simpler, but again, teach you something that is in fact widely in use. So what we want to do now is to break this down into words. So you can see, for example, that the first lyric starts with, "Oh, get me away from here." And we're going to break it down into the words such that each row is now a word as opposed to a full line. But we also want to maintain that information about the line number as well. So the tidy text package has a function called unnest token. So each one of these words in this case is a token. And it basically what it does is it unnests that lyric. So makes it a longer data frame where each row is now a word from those lines. And we are still also keeping the line number in mind. So we still know which words come from which line. So I'm here comes from line number 1, but play comes from line number 2. So this is the idea, and we can think about tokens as words. We can think about tokens as 2 words at a time, which we call bigrams, which will help us detect things like, for example, if I had a word where I say I am not happy, if we were breaking it down by words, you might say, oh, the word happy is in here. Maybe she means to say she's happy. But if you think of not happy, then you can actually detect that, oh, maybe the sentiment isn't so positive. So we're going to talk about bigrams as well. And then by the end of the week, we're going to be talking about sentences too, not necessarily automating extracting sentiments from sentences, but instead making predictions on a sentence base. So for now, we're going to do this unnesting our text into words or into bigrams and then visualize them. The text that we're going to work with is not song lyrics, but we're going to return to something we've seen earlier in the course, which is the COVID-19 speeches that First Minister Nicola Sturgeon gives, maybe not daily, but many times a week, and depending on the stage of the pandemic since last March, for a while she was doing these daily, and then for a while the frequency reduced over the summer, and it feels like, I think nowadays it's almost daily, that there are speeches again. And the Scottish government publishes the text for these speeches on their website, so that is the text that we're going to work with. Instead of walking you through all of this in slides, what I am going to do actually is return to our studio and do a little bit of live coding, and also walk you through the markdown documents that has the full analysis in there. There are really two reasons for this. One of them is so we can do a little bit of live coding as we go. And number two is so that you can see a repository with a full analysis in it, from beginning of data scraping to doing some text analysis, building an interactive web application, and doing a prediction model, building a predictive model using machine learning methods, which are the three things that we're covering this week. So you can see everything in one place, and the repository looks something like this, which you will, it is a public repository, so you can, if you would like to go through and play along with me, you can take the URL from here and bring that, clone it into our studio and work on it. You won't be able to push back to this repository since it's not your repository, but it is public such that you can clone it and take a look at the code and play along locally. Or if you would like, the first thing you might do is actually fork this repository. So when you go to fork a repository, that's on the top right corner, what it does is it basically creates a copy of a repository for you. It's kind of like a fork in the road as opposed to stick a fork in me. So you take a fork in that road at this point in time, and it will create a copy for you that you own now, so that you can push to it as well. That fork will not automatically get any of my updates if I do actually make updates to the repository going forward, but at least you can play along, and if you want to make changes to anything that I've been working on, you can do that and push it to your repository. So now we're going to return our attention to our studio and actually go through this analysis. Okay, so we're going to start our analysis by actually getting our data, and I'm not going to go into the details of this since this is something we've covered early on in the web scraping unit, but remember that these speeches are published by the Scottish Government on the Scottish Government website, and first we check to see, are we allowed to scrape these data? And the answer seems to be yes, and then we can load the packages, and most importantly we make use of the rvest package here for our web scraping. And our process for doing these was to take a look at the main page that has information on all of the speeches, and then extract from that the URLs for these speeches. So we can take a look at these URLs. There are 160 of them. Then we wrote a function for going to each one of these URLs and getting out information like the title, the date of the speech, the location, the abstract, and the actual text, which is the majority of what we're going to focus on today. We combine all of these in a tibble. And then once we have our function ready, we can use the map DFR function, which allows us to iterate over these URLs. So these list of URLs, and then as a applying this function that we just created, and then return to us a data frame, basically. And that data frame is called COVID Speeches Scot. I'm not going to run that code right now. I've already ran the code before and saved the result. And so what I'm going to start with in this, in the text analysis bit, is the reading this data set in. So let's go ahead, and I'm going to restart my R so that we can start with a clean slate and go ahead and load the packages that we're going to need, and then actually go ahead and load our data, which we're calling COVID Speeches Scot as well. So let's take a look to see how big this data set is. It should have, based on what we saw before, 160 entries and 6 variables. The names of these variables are title, date, location, abstract, text, and URL, which is basically what our function was spitting out. Now, I want to take a look quickly at the date variable. So I'll say select date. And we can see that these dates are given to us in year, month, day format, and it is a date column. But something that might be interesting potentially for our analysis is what day of the week was the was the speech actually made on. So using the wday package from wday function from Lubridate, let's go ahead and give it a try for one of these dates. So I'm actually going to just put this in here, and it tells us that the 25th of November was a Wednesday, which sounds right. So basically what this mutate step is doing is creating a new column in our data frame called wday that's going to spit out the name of the day for us in the abbreviated format. And then we create another column called weekend, which basically will label these dates as either happening during the week or weekend. At some point, I think they were doing weekend speeches early on in the pandemic. I feel like I haven't seen much of those lately. So we might want to identify them for later as part of our data prep stage. Another thing I want to do is take a look at who actually was the speech given by, because on that website, if you go to the main Scottish Government website and take a look at the speeches, the COVID-19 speeches, you'll see that many of them are by the First Minister, but not all of them. So this information, actually, we don't have a specific field for it, but we can see in the abstract that it's often stated in the abstract of these speeches who did the speech. So usually it says something like statement given by so on and so forth. So in this case, these are statements given by First Minister Nicola Sturgeon, but some of them actually show other people. So what we're going to do is create another variable called speaker as well, and we actually are just going to limit our observations to First Minister speeches here. So we can, just take a look at the, see if we can detect the character string First Minister in the abstract column. If yes, then we're going to label the speaker to be First Minister. If no, we're going to label it to be other. And then one last thing that I am going to do is to count the number of words. So in this case, we are using a new function that we haven't seen before from the stringar package, which we have seen before, that basically counts the number of matches in a string. So this is not necessarily counting the words directly, but we can use a particular regular expression to say we're basically looking for words. So they're going to be separated by spaces, or if it's at the end of the sentence, it's going to have a period after. So we use this regular expression to count the number of words in each of these text cells. And then we want to sum those up, because ultimately what we're looking to do is to say how many words in each of the speeches. So let's go ahead and run this code and take a look at a few things. So now we should have these new columns, and we might want to see, let's say how many day. So we can see, for example, that there was one Saturday speech only, and then 7 Sunday speeches, but many of the others are during the week. We can take a look to see, in terms of the speaker, 157 of these 160 were given by the First Minister, and the others are just 3 of them. So what we're going to do is we're going to kind of remove any of the speeches that are not given by the First Minister. And then I'm doing one other thing here, using a new function called row ID to column, just so I can record the speech number that's going to come in handy for us later. So if we now take a look at this data set, we can see that we have as the first variable a new variable called speech now, and it basically gives us the row number for these speeches for the time being. But once we actually unnest our tokens and split these into words as opposed to speeches, it's going to be helpful for us to have maintained this information on which speech did the text come from. Okay, so that's our part of our data prep stage, but that was really not text analysis as we talked about it at the beginning of the video just yet. The next thing we're going to do is we're going to actually split our data into words, so unnest our tokens. And so that's the functionality that we're using from the tidy text package. But before we get to that, I want to make one correction to our data. There are many ways in this data set how the word COVID-19 is spelled. So sometimes it is in capital letters with a dash in between. As you can see here, sometimes there's no dash. Sometimes it is title case with a dash, and sometimes there is no dash. And what I want to do is to make sure that these COVIDs and 19 stay together, as opposed to the number getting kind of split off from the word, since that's a meaningful phrase. And I also, when I count the words, want to know how many times we're referring to COVID-19 in this. So I want to make sure that however it was recorded in the original data set, it is actually now recorded as COVID_19. So I came up with something that's consistent across all. So that's what we're going to use. So it's a step that we might want to take when you know a particular feature about your data. That you want to make sure that you want to maintain these texts. And in this case, obviously, COVID-19 is an important one. So I'm taking this data frame that we created, doing this quick fix to my COVID-19 text strings, and then I'm unnesting the token. So let's go ahead and run that. It takes a little bit of time, not a long time, but a little bit of time, because it's actually now creating, as you can see, a data frame of over 300,000 rows for us. And each one of those rows is a word from our data set. So what I can do is I can say relocate word, just so it can come to the beginning of my data set. So it seems like the text started with good afternoon, thank you for joining us, I will give you, so on and so forth, which sounds exactly like how Nicola Sturgeon sounds at the beginning of her speeches. So this is basically our unnested data set with the words as rows. And another thing that we might want to do later on is also get the bigrams as well. So in this case, the only difference that I have is I am unnesting the tokens initially by word, and in this case by bigram. So if you take a look at the unnest tokens function, you can see that you might choose different tokens as well. So your tokens can be words, which is the default, could be characters, so it could be splitting by each character or character shingles, n-grams, skip n-grams, sentences, lines, paragraphs. If you're working with tweets, you can do it by tweet as well. So we're not going to go into all of these special functionalities, but we are going to use the basically the bigram option here. And so let's go ahead and run this. And take a look at these bigrams. Okay, so for example, we can see things like today's statistics happened 11 times in our data. 880 positive happened 20 times, which is very specific, interesting. Reported yesterday happened 23 times, so on and so forth. All right. No, actually, that is not right. No, so these are not counts. I think these are just the indexes. I'm sorry. So this is not a summary statistic. We are going to look at summary statistics, which, you know, the thing that gave that away to me was 880 positive happening 20 times, like exactly that many times. That number of cases becoming positive seems ridiculous. So those indexes are the line numbers that we're looking at. So let's go ahead and set this aside. Basically, the important thing here is that this is the sort of thing that a bigram is, and we're going to save these data as well as COVID speeches Scott bigrams. So we have our words, or we have our full data, we have our words, and we have our bigrams. And so at the end of this, I am actually saving these. And now let's go on to visualizing these data. I'm going to open up the third file here, which is in our markdown file. So the first two were R scripts because I was kind of just doing this data scraping, data cleaning, and then saving the data sets as a result, as opposed to doing that data cleaning inside my R markdown file, which would mean that every time I knit it, it actually has to redo the analysis or the rescrape the data for me, which is something I didn't want it to do. So let's go ahead and set this up. So I have a bunch of packages that I'm using. I'll talk about them as we use them. I'm going to make my font sizes a little bit larger on my ggplot2 figures. And I also looked up the blue of the Scottish flag, and that's the blue that we're going to use in our visualizations. Some setup for the size of my figures that is only relevant when we knit the document. And finally, we're reading those 3 data sets that we created. One of them is what we scraped, the other one is the bigrams, and the third one is the words that we're working with. So the first thing I might do is take a look at the length of speech. So here, because I had already calculated the number of words, I can basically plot that kind of over time, right? So these speeches are happening over time anyway. No, so this is a density plot, sorry. We're just looking at the density of the data, so the number of words, and we can see that the mean is 2,000. So on average, we have 2,000 words that are being spoken in each of these speeches, which maybe makes sense in terms of the length of the speech. I feel like she talks for maybe about 15 minutes or so, about that much before there are questions. So the distribution looks pretty symmetric. We do have a long tail. So another thing we might take a look at next is actually these what this might look like over time. So I'm going to go ahead and run only part of this for a second so we can take a look. So here are the points over time that we can see. Maybe there's a positive trend somewhat, I'm not really sure, but each of these points represent a speech, and on the x-axis we have the date. We might fit a smooth linear model to this. So we are seeing a positive slope. So maybe over time, the speeches are getting longer as the pandemic is dragging potentially. And another thing I have done here is I've fit a model and then saved the R² of that model. And then I'm just kind of adding that value to the title of my plot. So the R² is pretty low, 13%, and we are seeing a lot of scatter over this line. So even though it might look like, it does look like there is a positive trend, it's certainly not a strong one. So to say that definitely the speeches are getting longer on average is probably going to be not very meaningful because there is a lot of scatter. So it seems like there might be a lot of random noise. But at the same time, we are seeing somewhat of a positive trend, which might be interesting to take a note of. Okay, so this was working with the data so far, the data that were created, but let's take a look at the words. So what I'm going to do here is we have our words data frame, and I am going to count the words so that in order of frequency. And we can actually see that when I count the words, the most common word is something like the, and then to, and then and these happen so many times. So I can plot these data as well here. And when I'm plotting it, because there are so many words to plot, I don't want all of them. So I said, give me only the words that appeared more than 1,000 times. And if we look at this plot, there's barely anything interesting here because the most common words are what we might call filler words or stop words is what they're called in text analysis. So there is actually this concept of stop words, and obviously these change from language to language. So there are word bags like this for other languages as well. But what we really want to do is when we're doing our text analysis, take away these stop words unless that's what your focus of your text analysis is about. But here I'm looking for what common words about the pandemic or about healthcare or public health is the First Minister talking about, as opposed to what filler words she uses. And so we're going to say we want to take away these stop words, and we can do that using the anti-join function. So this list of stop words is something that comes with the tidy text package that also leverages other packages that work on natural language processing for collecting this information. So we're going to go ahead and anti-join these this data frame of stop words, and then let's take a look at our counts again. So now we are actually seeing that the words that appear on top, the most frequent, are things like people, virus, Scotland, health, yesterday. These seem a lot more like things that we would expect to see as common words. So I'm going to give a threshold of 400 here. So in terms of figuring out how many words to plot, so I'm going to give a threshold of if a word appears more than 400 times, let's plot it. And so this is what our visualization looks like now. People, virus, Scotland, health, COVID-19 obviously shows up here towards the bottom. The word test shows up. COVID on its own shows up. Restrictions, unfortunately, deaths. So these are all things that we would expect to see, I think. And it looks like among these people, and then the virus is the most common, followed by Scotland. So this is about counting things, but another thing we might want to take a look at when we do text analysis is what about the sentiments in them? Which is a hard thing to think about. If I was to tell you, I am happy, you as a human can tell what the sentiment in there is. It's a positive sentiment. And if I was to say, I am not happy, you as a human can tell that actually that's negative. But if we are just looking at words at a time, those sentiments are going to be potentially not as reliable. So that's something we want to keep in mind as we venture on to doing this sentiment analysis. Other things that you might think about is when we have sentences that have both negative and positive words in them. I love to hate you. I hate to love you. I'm not really sure. Is that a positive statement or a negative statement? It has one positive and one negative word in there. So in that case, the way a human might perceive that sentence might be different than when we're doing matching of these words to particular bags of words that have sentiments attached to them. So there are these sentiment dictionaries or lexicons that we might say, and they usually refer to whatever research they were created by. So researchers who work on natural language processing actually come up with these bags of words, and the tidy text package makes these available for us. So for example, based on the Bing lexicon, something like abnormal, abolish, abominable, I can't say the word, basically are negative sentiments, but we can also find words with positive sentiments. So let's go ahead and do a filter. Oh, this should be filter sentiment equals positive. So abound, abundance, accessible, acclaimed, acclamation, these are all positive words. So we basically have a bag of words like this, and we can see that there are basically, how many in total in this bag of words? 6,786 words that have sentiments attached to them. So what we're going to do is we're going to start with the words that we have in our data frame, and then we are going to inner join. So take a look to see which ones are in common between the bag of words that come from the Bing lexicon, and then join those. That way, for each of the words in our Scottish COVID-19 speeches, if there's a word that in there that has a sentiment attached to it, we want to keep it. Any other words that we don't have sentiments attached to them, we're not going to be able to use. And then we're going to go ahead and group by the sentiment. And let's take a look at the top 20 of each of those. So let's take a look at this. And here we go. In this case, some of the negative words are things like virus, risk, difficult, symptoms, which all I think make sense. But then on the positive side, one of the most common positive words is the word positive, which in many other cases would have a positive sentiment. In this case, though, COVID-19 positive. So when the First Minister is talking about number of positive cases, I don't think we humans would actually say that's a positive sentiment there. We're talking about a test result. So even though the bag of words basically claims that this should be a positive sentiment, what I am going to do is I am actually going to get rid of the word positive. So I want to filter my words from my data frame for any word that is not positive, and then do the same thing again, just so that positive word does not show up on the positive sentiment side. So now we're seeing basically on the positive side, common words are support, protect, guidance, loved, helping, well-being. These are all things, in fact, we would place positive connotations to. It looks like the word virus shows up a lot. So on the x-axis, we can see the scale. And that is a word with a very kind of negative connotation. But if we actually kind of forget about the word virus for a second, we can see that on average, the rest of the time, the positive words appear a lot more often than negative words. For example, if we were to compare the axes, these words go out to like above 400 on the positive side, but over here, things like risk, difficult, isolate, death, so on and so forth, those are appearing a lot fewer times. So perhaps we can't necessarily infer something from this, but it is kind of good to see that on average, perhaps we're maybe trying to keep some of the tone positive. Let's see if that's true. The next thing we can look at is how has the sentiments changed over time? So I'm once again going to remove the word positive from here, and I am going to again join the words that I have with the dictionary or the lexicon that has the sentiments attached to them. But this time we are going to make a plot of the positive and negative sentiments over time. But how are we going to do this? So one of the things that I'm doing here is go ahead and take a look. So one of the things that I am doing here is looking at, for each of the days, how many negative and how many positive words there were. And then I'm going to do a pivot wider so that I can actually get these in two separate columns. So on March 17th, there were 25 negative words and 24 positive words. So then the sentiment for that day should basically be -1. So we're doing positive minus negative to get to that. So this is the sentiment column that we're going to work with. If it's a positive number, there were more positive words. If it's a negative number, there were more negative words. And the magnitude of the number tells us in which direction the speech skewed. And we can go ahead and plot these over time. So above the line are positive and below the line are negative. And we can see that for many of the days, the overall sentiment is negative when we add up these scores, which probably isn't surprising given the context, but that's basically what we're seeing here. We can also take a look at it with a smooth curve to see if there is a kind of a trend of some sort over time. But I would say that this line looks pretty straight, such that I don't think it would be necessarily fair to say the sentiment necessarily has been decreasing either. It has mostly, it seems like, being sitting stagnant at that level. There are other lexicon that we can use. So in the Bing lexicon, we were able to assign just the words positive or sentiments positive and negative to it. Another lexicon called NRC actually gives us sentiments like, let's just say, trust, fear, negative, sadness, anger, surprise, positive, disgust, joy, and anticipation. And so some of these are negative words to begin with, and some of them are positive words to begin with. So we can do the same inner join step to take a look to see how these various sentiments apply to our words. So we can see what are some words that we might classify as anticipation or joy or surprise or trust versus some that are more like sadness, anger, disgust, or fear. So for example, the word death shows up under anger. The word confirmed shows up under trust. But I'm not necessarily sure that that is a trust, like a positive sentiment trust statement. It is more probably about how many confirmed cases there are. So we're seeing some of these things show up as things that make sense in terms of the sentiment assignments. And some of them, it looks like, are showing up as perhaps a mismatch because of the context that we're dealing with. So this sort of assigning sentiment to our assigning sentiments to words in this way of doing a one-to-one matching is in some ways very powerful, and in some ways can yield results that are not necessarily very sensible in context of your data. So in that case, you might want to fiddle with how you're doing these sentiment assignments, or maybe say that depending on the context of what you're working with, maybe the sentiment analysis of this sort doesn't make sense. Here's another look at those same sentiments, but this time we're looking at them over time. So we've done the same steps here, but on the x-axis, our only difference is that we have date on our x-axis. Just to check to see if there has been particular sentiments that have been going up over time or staying the same. It looks like many of them are honestly staying the same, potentially slight positive on the trust side, and perhaps as a vaccine is starting to become a viable solution out of this pandemic, perhaps we're going to see some of these sentiments change over time if everything goes successfully in the near future. Okay. Another thing that we might look at, we talked about, were bigrams. So let's go ahead and talk about those for a second before we wrap this video up. So far we've looked at a single word at a time, but what about bigrams? And one thing that I've done when I'm working with bigrams is, let me go ahead and run this this commented out for a second. So this is working with the bigram data that we had created earlier. So these are the bigrams that are, so the most common pairs of words that are showing up. But I think we had, so care homes showing up sometimes, and then sometimes it's just a care home as opposed to multiple care homes. So what I did is I actually said, if you see care home or care homes, convert them all to care home with S in parentheses, just so we can combine those two, because we know that that has definitely been part of, an important, unfortunately, aspect of what's going on in this pandemic, and something that the First Minister speaks very regularly about. And here we're looking at bigrams occurring more than 75 times. So we can see that care homes kind of jumped up. So they say Scottish Government a lot. They say intensive care a lot. They say care homes a lot. Tested positive, public health, 24 hours. I can kind of hear her saying in the past 24 hours, this is what happened. I think stay home and save lives was something that was being said a lot early on. So that's probably what that's about, and talking a lot about care workers and public transport and so on and so forth. So we're not going to assign sentiments to these bigrams, but it's useful to see what are the ones that are occurring most regularly. And the last thing that I want to talk about before we wrap things up is something I was curious about, which is that early on in the pandemic, we talked a lot about social distancing. And then at some point, I remember there was talk about, well, we're not necessarily asking people to socially distance from others. In fact, with people being stuck at home, that has a huge effect on mental health as well. So the conversation changed from social to physical distancing, because really what we want to do is physically distance ourselves from others when we're out in public, so that transmission is less and less likely. But at the same time, we're not saying you can't talk to your family and friends. You should still try to be social, if only virtually, so that you can actually keep your mental health in place. So that what I did here is I said, let's take a look at these bigrams. So we're basically starting with these speeches, and I'm nesting the tokens for the bigrams. And then I say, anytime you see social dist or physical dist. So sometimes it's social distance, sometimes it's distancing, or sometimes it's distant. So in order not to make a distinction between those, I said, if you see any one of these, filter them. So we can take a look to see how many times these got said. So it looks like 140 of these bigrams include either social dist or physical dist. And there were 157 speeches, so it's like we say it almost, it seems like on average once or a little less than once per text. And then we create a new variable called soc or site or phys, and that's basically saying if you detect the word social, put the letter S, otherwise put the letter P for it. And then we're going to count for each days how many times they said either social distance or physical distance. So for example, in March 22nd, very early on in the pandemic, we said 3 times social distance and no physical distance. Then we basically plot this over time. And one of the things I'm doing here is instead of using geom point, I'm using a geom text, which basically places that text as the label on my plot. So S's are for social and P's are for physical distancing. We can see that early on in the pandemic. The First Minister was saying social distancing a lot. Around April time or May time, there was like a mix of these. And then it seems like June onwards, the word has only been physical distancing. And it looks like for we're saying these pretty regularly over time, sometimes multiple times. It looks like in July there was one speech where she said physical distancing 9 times. So perhaps there was a spike at that time in terms of transmission that needed to be said more. But it looks like for many of the speeches she is saying it at least once. And lately, that has been about physical distancing as opposed to social distancing. So what we talked about in this video was to take our text and tokenize it into either words or bigrams. With words, we also did a little bit of sentiment analysis. Some of that produced results that were interesting to look at and perhaps conveyed something useful for kind of deciphering what the sentiment has been in these speeches. And some of that we saw was a shortcoming of that approach where we were assigning particular sentiments to words where in context that sentiment didn't necessarily make sense. And then we also did a little bit of data wrangling to take a look at this social and physical distancing thing. That's, on one hand working with text data and using a lot of basically mixing and matching our use of the tidy text package, which gives us specific text data functionality, with the stringar package, which generally allows us to work with character strings to actually see the trends in some of the vernacular in the First Minister's speeches.